Hello everyone, thank you for coming back to watch this video. I am Sosale Mohana. I'm a maths teacher, but I spent half a decade teaching maths at A level or equivalent to A level. So I'm just recording these lessons for the benefit of students who might be doing high school diploma or the British A level or the AP courses, or in some cases the maths pupils might do in America in freshman and sophomore years. So I hope they're useful to you. I'm coming back to where we stopped last time and then what we're going to do now. We finished the application of the binomial series and I said we're going to start algebra. Now we are on topic 5. Remember, topic 1 was numbers, topic 2 was basic algebra, topic 3 was algebra, topic 4 was coordinate geometry. Now we are in topic 5. Topic 5 is going to be a long topic. Familiar. Trigonometry. In my language called geometry, meaning to do with a surface. Trigonometry, triangle. Trigonometry, trigonometry. I don't know whether trigonometry came from trigonometry or trigonometry came from trigonometry, doesn't matter. We are on familiar ground. Oh, socato. Suddenly I can hear somebody saying socato. So you know from your GCSE that if you have a right angle triangle, if that angle is theta, I love the moment we come back to theta, alpha, beta. This is the opposite side. We call it as O. This is the adjacent side. We call it as A. And that is the hypotenuse, which we call it as H. Whereas sometimes some people use perpendicular and base. So that's also called perpendicular. I'll just put perpendi so that you understand that. And this is called the base. Because when I learned this. Some people have SPH. Some people have curly brown hair, cosecant to paint black, TPB. Okay, let me just put that. Some people have curly brown hair to paint black. This is how I learned trigonometry. But when I started teaching in Kenya, or when I moved to England, I had to reuse them as so, ka, choa. Which, remember, I don't know whether your teachers have taught you, this is how I use. Don't remember Sokatoa that way. I would remember them as these triangles. Same Sokatoa. Only thing is the way you write it. Because to find the opposite side, multiply sine and hypotenuse. To find the cosine, you divide adjacent by hypotenuse. To find the hypotenuse, divide adjacent by cosine. And to find the tan, divide opposite by adjacent. If you want to find the opposite side, multiply tan by adjacent. So it's easier to remember that way. At GCSE, of course. So you know sine is opposite by hypotenuse, cos is adjacent by hypotenuse. Look, the same thing here. Sine is perpendicular by hypotenuse, cos is base by hypotenuse, tan is perpendicular by base. So your perpendicular is the opposite side, base is adjacent side, so it's nothing different. So you know that. I'm not much interested in that, and you know how to find the sine rule and cosine rule. I'll take some examples on sine and cosine rule if necessary later. At the moment, I am not interested in those. Because we are now in A level. Remember, I told you we have gone beyond Sokotova. So, let's put it in perspective. I have a right angle triangle. I'm going to call this as A, B, C. B squared plus A squared plus B squared is equal to C squared. Something like that. Then that should have been C. Doesn't matter. So now this is the opposite side. That is the adjacent side. That's the hypotenuse. That's the angle theta. I want to write what is sine theta here. Sine theta is opposite over adjacent, which is, hypotenuse. AB over AC. What is cos theta? Adjacent over hypotenuse. BC over AC. What is tan theta? Opposite over adjacent, which is AB over BC. When you look at sine and cos, what happens when you divide sine theta by cos theta? Will be AB over AC divided by BC over AC. In GCSE you learned AB over AC times AC over BC, which is AB over BC, which is tan theta. That is another definition of tan theta. Tan theta is also known as sine theta over cos theta. Actually, it is cosine and tangent. Way back in the time of Euclid, they found out this. I think Euclid or Pythagoras, I'm not too sure. Way back in the Greeks. That's why I'm honoring them by using the letter theta. Sine, cosine, tangent. So we continue to use them. If they had called it as something else, we would have used another name. But they called it as sine, so we have to use sine. Okay, and cos. Now, what is 1 over sine theta? Will be AC over AB, which is hypotenuse over opposite. This, they called it as, I'm introducing you to 3 more new ratios, cosecant theta. Cosecant or cosec theta. Cosec theta is 1 over sine theta, which is AC over AB. Similarly, what is 1 over cos theta? Is AC over BC, which is hypotenuse over adjacent. So, that is secant theta, we use sec theta, is 1 over cos theta, which is AC over BC. And also, we did 1 over tan theta, which is adjacent over opposite, which is A over O. So, we call that as cotangent theta or cot theta is 1 over tan theta, which is BC over AB. When you do 1 over of that, it is also cos theta over sine theta. So those are, so in other words, I have introduced you to 3 new ratios. People in year 12, you may learn it in year 12 or you may learn it in year 13. But people in India, obviously, they learn it at GCSE, not even A level. Good. Now having done that, the biggest problem I have, which is standard, is always what is sine theta whole squared? Is it sine theta squared? Is it sine square theta? Or is it sine square theta squared? Remember, sine theta is a ratio. It's a number. when you're squaring sine, which is basically sine theta times sine theta. That means you're not squaring the angle, but you're squaring the ratio. That is why we write it as sine squared theta. If you want as an experiment, do sine 30 is half. What is sine 30 whole squared? Is sine 30 times sine 30, which is a quarter, or that is sine squared 30. What if it is sine theta squared? Will be sine 30 squared, which is sine 900. If you use a calculator, you get the answer as 0. And if you do sine square theta squared is sine 900 whole squared, which is still 0, whereas the actual value is a quarter. That's why when you say sine theta whole squared, it is sine square theta. When you say sine square theta, when you say cos square theta, when you say tan square theta, what you are doing is you are squaring the number. You're not squaring the angle, you're squaring the ratio. So by convention, when you say sine squared theta, it means it is AB squared over AC squared. If you say sec squared theta, it is AC squared over BC squared. If you say cot squared theta, it is BC squared over AB squared. So now that that is clear, now I want to spend a little bit of time on this. I want to use the same triangle. That's the angle theta. That is A, that is B, that is C. I've got those. What is that thing which you have learned from year 10 and keep using it? Can you guess? Penny for your thought. Pythagoras. Oh, sorry, Pythagoras. So what's Pythagoras? AC squared equal to AB squared plus BC squared. Or if this is small c, that is small a, that's small b squared equal to a squared plus c squared, at least different from a squared plus b squared equal to c squared. Very good. Now, this is Pythagoras, right? It's true. Whatever, look, do I know the length of AC here? I don't know. Do I know the length of BC here? I don't know. Do I know the length of AB there? I don't know. But when you find the lengths and divide and square them and use this relation, it will always be true. What happens if I divide this by AC squared? What do I get? I get AC squared over AC squared equal to AB squared over AC squared plus BC squared over AC squared. What is that? 1. What is AB over AC? Look there. AB over AC is sine theta. Remember just now I told you, so that is sine squared theta. What is BC over AC? Cos theta. Cos squared theta. So I can say sine square theta plus cos square theta equal to 1. Did we know the theta there? We did not. Do we know what is sine theta there? We don't know. As long as you take the same angle theta, square its sine, square its cos, and add them together, the answer will always be 1. That's called an identity. That means true for any value of theta. It's called an identity, which you have come across algebraic identities in your year 12. Now let me take the same relation. I have done, remember I have done AC squared. So let's divide by AB squared. So I am dividing by AB squared. So I get AC squared over AB squared is 1 plus BC squared over AB squared. What is AC over AB? Cosec. So that will be cosec square theta equal to 1 plus BC over AB. BC over AB is cot theta. 1 plus cot square theta. So I have the second formula. Another identity. Look, we believe in equality. We believe in fairness. We divided by AC squared. We divided by AB squared. It's only fair to keep, I can't say, look, you do 10 questions, you do 2 questions in the class. That's not fair. If he does 10, you should also do 10. Yeah? So therefore, we have divided by AC, we have divided by AB. What did the poor BC do? So let's give him a chance as well. So divide by BC squared. I get AC squared over BC squared. I will first divide and write that as 1 AB squared over BC squared. Now what is AC over BC? Sec. So sec square theta equal to 1 plus AB over BC is tan square theta. These identities, if I come in your dream, when you're in A level, and ask you these identities, you should be able to tell me. Why? Because they're the most important identities to start with. We use them every often when we do calculus and other things. And they are not in the formula book. Of course, you can always derive them. But by the time you finish trigonometry, you'll have learnt about 15 to 20 identities. And if you're doing further maths, will be much, much more. So you can't remember 10,000 identities. So I remember the basic identities, and the rest I think you should be able to derive. Anyway, you're supposed to remember, because children in India, I don't remember about Kenya, do not get a formula book. No formula book. Either you know it and you write it, otherwise tough. So, but we don't use it always in this form. We might write sine squared is 1 minus cos squared is 1 minus sine squared. We might write cosec squared minus 1 is cot squared, sec squared minus 1 is tan squared, or we might write cosec squared minus cot squared equals 1, sec squared minus tan squared equal to 1. In different forms, the same thing. So I want to stop at that stage. I have introduced you to 3 more ratios. I haven't yet gone to the general angle. I am still sticking to what you learned in GCSE, but went one step, bringing some reciprocals. And I've taught you the 3 identities. Next lesson, I'm going to spend some time solving identities using algebra and these formulae. I'll stop at that stage. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.